All right, I'm back. We're on page 308. We just talked about what it means for something to be an absolute maximum or an absolute minimum. Remember, we're talking about y values, which means that you can have the same y value at multiple x values. The question is it the smallest possible y value or the biggest possible y value? If it is, then you're good to go. Otherwise, it's not. So the real question sort of becomes, not the real question, one question becomes like, when are you guaranteed to have these values, right? So we saw in these examples that sometimes you had an absolute min, but no max. Sometimes you had an absolute max, but no min. Sometimes you would have both of them, but it was still like an open interval. So we need to have some hard, fast rule that will at least tell us that something is definitely going to happen. And it turns out that there's something called the extreme value theorem, and this will guarantee that there is an absolute max and an absolute min. So what does it say? The extreme value theorem. So this is highlight worthy. So let's do this. Extreme value theorem says if f of x is continuous on a closed interval from a to b, so it must be continuous, doesn't need to be differentiable, just continuous on a closed interval from a to b, then f of x takes on a minimum and a maximum value on a to b. So one thing that's a little confusing is that we kind of bounce back and forth kind of loosely and casually between absolute max, absolute min, relative max, relative min. It's all context-based. So this is about absolute maximums and minimums. There will be an absolute maximum, absolute minimum. There could also be relative maximums and minimums, which we haven't really formally defined yet. But if you're continuous on a closed interval, then you guaranteed have an absolute max and an absolute min. So this recently has been emphasized. So recent emphasis on AP exam. So it used to be the case that this one kind of didn't get mentioned all that much. There are 3 value theorems, and we know 2 of them. So we know IVT, we know EVT, and someday, if you keep going, you will know the MVT, the mean value theorem, which is probably the most important of all of them. But intermediate value theorem, extreme value theorem, make sure you know these, right? So there are theorems that you're going to actually reference at some point. All right, let's do a problem here. Given the function f of x equals 1 over x with domain 1 to 3, that's really important. So it's a closed interval, and it's continuous on that closed interval. So there's guaranteed to be an absolute max and an absolute min. Continuous on a closed interval, guaranteed absolute max, absolute min. So 1 over x, use a graph and some common sense. Common sense? I don't know. Let's see. There we go. Okay, at 1, what should I go by here? I'm going to go by 1, 2, 3. And then I think on the y-axis, I'm going to go by thirds, which is kind of a weird choice, but 1, there. Okay, I'm not even going to label them. Like, it's up to the reader to work out what those are because I put a 1 there. All right, so 1, 1, closed point. At 3, it's 1/3, closed point. I mean, at 2, it's 1/2, if you really care about that, but probably not. Okay, continue. So let's write this up. So we'll say, since f of x is continuous on 1, 3, f of x has absolute max min on 1, 3. Okay, guaranteed. So, and we could say, and maybe we should say, by IVT. So let's erase that little dot there and say, by extreme value theorem, which you can definitely abbreviate. Okay, so guaranteed to happen. Let's see, just look at the graph, right? So this is a decrease. This is actually a thing to think about. If a function is decreasing on an interval and continuous on that interval, then it must be the case that the absolute maximum is at the left endpoint and the the absolute minimum has to be at the right endpoint. Like that has to be the case. The reverse is true for an increasing function. So let's answer this question, and then I'm going to kind of jot something down about that because I think it's important. All right, so the absolute max is 1, which occurs at x equals 1. And the absolute min, which remember is the y value, it's not the x value. So the absolute min is 1/3, which occurs at x equals 3. Okay, so what was I talking about with increasing and decreasing? So if, or where can I put this? All right, this is a little extra, so let's change it up. Let's do a different color. So, oh, and maybe a star. Okay, we're ready to go. If f is continuous on AB and decreasing, so continuous and decreasing, then the absolute max is f of a, absolute min is f of b. Like, it has to be true, right? So we know it has to happen somewhere because it's continuous. Since the function is decreasing, it has to kind of do this. So you can tell that the maximum will be there, the minimum will be there. Let's switch colors and kind of like address the other option. So if f is continuous on AB and increasing, so like what has to happen there? Just like think it through. So then, oh my God, that says then the absolute min is going to be f of a, and the absolute max is going to be f of b, right? And just draw it out. So there's a lot of stuff when you're dealing with calculus you can work out just by drawing a simple little picture, right? There. How could that not be the case, right? It's got to be continuous. Extreme value theorem then guarantees that there's an absolute max and an absolute min, but since the function's increasing, it has to be the smallest it'll ever be at the left endpoint and the biggest it'll ever be at the right endpoint. So let's see what this question says. Why can you do this generally for this example? No, why can you do this for this example, but not generally for this function? So you can't do it in general because, ooh, wrong color. Subtle, but wrong color I was about to use. F of x is not a continuous function. It's not continuous on the reals. So I'm going to say, since f of x is not continuous at x equals 0, let's say EVT. So it takes, this is in calculus, maybe more than any math class you've ever taken. Maybe in geometry, depending on the quality of the geometry class that you took. You have to like think about what you're gonna write. So I have a lot of like false starts, and then I go back and I'm like, no, I can do this better. So since f of x is not continuous at x equals 0, EVT does not apply to any interval containing x equals 0, right? So any interval containing x equals 0. So like -2 to 2, not going to work. -2 to -1, it's going to work because it doesn't contain 0. But in general, we can't apply the extreme value theorem to this function. We have to like really be careful about it and think about it and make sure we're choosing an interval on which the function is continuous. All right, so that's the end of this page. There's not a natural transition to the next page, so what I'm going to do is just stop here, and I will see you in the next video when we keep doing more stuff. So see you then.